Hi, in this video we will talk about functions with incomplete specification. Sometimes you have functions that do not tell you what to do in every case. Are you familiar with this? This is a window switch. And of course you can elevate the window or move it on the other way. So let's analyze these inputs and the output of this system. This would be the truth table. You have a switch that generates two signals. One when you press the up direction and another one when you press the down direction. So if both inputs are zero, well, the motor, which is the one that moves the window, is zero. If you press the down button, the motor is going to move in the down direction. However, the motor should be on. So in this case, I'm talking only about the state of the motor, which is on or off. I'm not talking about the direction. If I press the up button, but not the down button, I still want the motor to be on. Now the question is, what happens if both up and down directions are pressed? Well, in this type of switches, we cannot generate both inputs at the same time, because physically it's impossible that you press the up switch and the down switch from the same window at the same time. So in this case, this particular combination, well, in theory and actually in reality, it's never going to happen. So if it is never going to happen, what should I do with this combination? Well, the answer is simple. The answer is you don't care. It doesn't matter what happens with the output because this combination should never happen. We're going to do something that is called the don't care, which is something like a joker in playing cards. So we're going to put this into a D. The D symbolizes the don't care. Let's see another example. You've seen this in your laboratory. So this is an 8-segment display where we have segments from A to G. So what happens with its truth table? Well, we have something like this. For example, if we're at combination 0, that means that we want this, and this on. So in particular, by looking at segment A, we want it on. That's why here there is a 1. In combination 1, well, we want only segment B and segment C on, and because of that we want 0 in that combination. Now this you may already have understood. All these are all the combination, of course, all on T9. The 9th combination, which is this one here, I still want the segment on. But what happens in combination 10? Well, for combination 10, you actually need another segment. So this should never happen. This should never happen because you only have one digit, and one digit can go from 0 to 9. So what do you with this combination in this particular example? Well, you put a don't care. You don't care what happens there because this combination should never happen. Now, what happens with K-maps? When you have an incomplete specification function, the don't cares, which are the Ds, well, you can use them as they best suit you. Each D can become independently in a 1 or 0. How do you decide if it becomes a 1 or a 0? Well, whatever is best for the function to be shorter, that's what you should do. However, these Ds, because we don't care about them, they cannot be marked as essential. And this is the step in the algorithm where you put an asterisk. And you should use them so that you can minimize a function even further. So let's see an example. Here's a function which is dependent on A, B, C, and D. We have a list of min terms, which are the ones that we are sure that we want. We have the list of max terms, which are the ones we are sure that we want the function to be 0. But we also have a list of don't cares, and those don't cares, that mean that those combinations, we don't care what happens with the function. It can be either a 0 or a 1. So we go with the same numeration we have seen. 0 here. I'm gonna go down now. So 1 here, 2 here, and 3 here. It's the same pattern, just instead of horizontal, it's vertical now. So now I have to fill the variables, and the variables would be D here because of the 1, Z here because of the 2, B here because of the 4, an 8 here because of the 8. Now I fill the zeros. And now I will fill the donkers. Here's the tricky part. Before you only fill the zeros or the ones, and then you started solving the K-map. Now you have to put the donkers. Well, the donkers in this function are in the 8. The next part is the same. You will still use the same algorithm, the same time of grouping. The only thing that's going to change is that, well, you don't care at the end, you don't care about the donkers. It's kind of obvious. But right now, think of the donkers as zeros. Think of them as zeros for now. So we're going to start grouping zeros and donkers. Think of them as zeros. Okay, so we finished finding groups of zeros. In this case, remember, we thought of donkers as zeros. Now you have noticed that I have put an asterisk and a question mark on two groups. And here, even if I told you that think of donkers as zeros, you might omit these two groups. Group number 3 and group number 7, we can't omit them. Why? Because we are only grouping donkers, and donkers, we don't care about them. However, you're seeing in group number 4 that you should not omit, because even if you're grouping one donker, you're still grouping one zero of the function. Now let's find the asterisks. In this case, I don't have a donker with only one group grouping it. But if I had one, you should not put asterisk in a donker, because donkers are not essential part of the function. We only care about the zeros. We only care about covering the zeros. So now that we found the asterisks, we know that group number 1 and group number 2 should be part of the solution. I'm gonna cross the zeros that are covered by those two groups. With group number 1, I cover D0, D0, and D0. And with group number 2, I cover D0. Then I have the option, or not the option, I have only one zero to cover, which is not essential. So you can see that this has two solutions. In this case, the complete way to solve this function would be group number 1, dot, because we have max terms, group number 2, dot, and then I have two options. I either go with group number 4, or I go with group number 6. And this is how you take care of donkers.